For sample problem 1, we're going to take a look at how we would write set and interval notation with a given graph. So you can see the number line, and we have a shaded portion of the number line that we need to write in different ways. So first I'll need to identify the type of interval. And if we recall from the previous page in this set of notes, that if it's got an open circle and it's got a closed circle, it could be either considered half open or half closed. So either way, if we simply say, so for part A, we'll just simply say that it's half open. I'm a half full kind of guy, so we'll go with the half open interval. So part B asks us to simply write the set using set builder notation. So technically, what you really want to think about doing is, how would I write that number line, what's shaded on the number line, as an inequality, as a range of values? And so I kind of back my way into it a little bit this way. I say, you know what, I have -5, I have a 3, and we're taking all of the x values that are between -5 and 3. Now, one of the things that we have to account for here is whether it's an open or closed circle. So we have an open circle at -5, so we know that it is not equal to it. Yet we have a closed circle at 3, so we have to write the equal sign beneath your inequality. Now, we need to do this in set builder notation. So this is basically represented with an x and the brackets, and so that suggests that the set of all values of x that are between -5 and a +3, and so that's set builder notation. Now, we could also write this in interval notation, and so basically our interval notation would be between 5 and 3, and one side being parentheses for an open interval and one side being a bracket for a closed interval. And so that's what that would look like in interval notation. Now, here's the thing. Keep in mind as well, like if I had -5 and I had a +3 and I wanted to redo this, I could easily graph it with the bracketed parts instead of an open and closed circle, and so you could see it look that way as well. So that is another possible way for you to graph that number line. So there is an example of set notation and interval notation, and so let's go down to sample problem number 2 and see if you can work the opposite way. So in sample problem number 2, it simply asks us to write the set with -3 infinity in set builder notation and graph the set on the number line. Well, if I were going to write that as a range of values, what it's basically saying is this, that we're going to go from -3, and it's closed, okay, and then it's going to go to a positive infinity. So it's going to go on this direction forever and forever. Okay, and so that's what it's going to look like on the graph. Now what we need to do is be able to write that basically as an inequality, if you will. And so we have all of the x values that are going to be greater than -3. So all the x values are going to be greater than -3. The closed circle, or the bracket, also suggests that it could be equal to -3. And so now, to complete the set builder notation, I just have to put my little bar and my x and my little brackets. And that suggests that the set of all x values such that x is greater than or equal to -3. And so that would be set builder notation for that one. Alright, so let's take a look at part B. For part B, it was given in set notation, set builder notation, and now we want it in interval notation, and so we want to graph that on number line as well. I'm just going to go ahead and take the range here. I have an open, looks like I have an open at -2, and I have an open circle at 5, and it's the x values all between here. So we're going to shade all of the values between -2 and 5. And the way that I would write that would be -2, 5 with open parentheses on both ends, and that would be my interval notation for this. Now, do not confuse this with a point, an xy coordinate. Okay, this is representing an interval of values on a number line in a certain way. So just got to keep that clear in our head as we go. Alright, so in the next video we'll discuss unions and intersections.